Hey guys, welcome back. Last but definitely not least, in chapter 0, we are solving systems of inequalities, and we have to do this by graphing. Let's talk about why. Because a system of inequalities has an infinite number of solutions, it has to be shown on a graph. The way to graph these is to graph each inequality. Use a solid line if it has an equal sign under the inequality symbol, and a dotted line if it doesn't. Shade above the y-intercept if it's a greater than inequality, but below the y-intercept if it's a less than inequality. If you can't figure out what's above or below the line, you can always use a test point to figure that out. I would recommend 0, 0 as long as it's not a point on the line. If the test point comes out true, that means that region should be shaded. If the test point comes out false, that should not be shaded. Next, the solution is the region where all the shading overlaps. So if you have two lines, you're looking at where do those two shading regions overlap. That's the solution. It's a whole entire section on the graph. And finally, step 3, you can check that solution. If you test a point within the solution region, it should make both of the inequalities true. Let's get into an example. If we want to solve this system of inequalities, we have to graph the two inequalities on a coordinate plane. So let's first take a look at these and notice that they are both in slope-intercept form. For the first inequality, we're going to graph the related equation. Y equals 1/2, I'm going to write that as a fraction, x minus 3. The reason why I'm writing that as a fraction is because it's the slope and it's easier to see now that the graph goes up 1, right 2. It's a positive slope, so it should be increasing. I know I'm going to use a solid line because it has an equal to symbol under it. And I'm going to shade above the y-intercept because of the fact that its y is greater than. For the other, I'm going to graph the related equation y equals negative 2x plus 7. For that equation, it has a slope of negative 2, which is the same as negative 2 over 1, meaning that I should go down 2, right 1, in order to make that line decreasing, using the y-intercept of 7. I'm going to use a solid line because it has an equal sign under the inequality symbol. And I'm going to shade below the y-intercept of 7 because it says y is less than or equal to the equation. So let's go to our background and make a coordinate plane. I'm going to assign each of them a color. I'll use pink for the first inequality and blue for the second inequality. First, pick out the y-intercept. It's negative 3, so I'll place a point on negative 3. And like I said, I'm going up 1, right 2. Just like solving systems of equations, when you're solving systems of inequalities, you'll want to have a really precise line. So even though 2 points is enough, I would recommend doing more. We also already talked about how we will use a solid line because of the fact that this is equal to, y is greater than or equal to the expression. And then we also said that we are going to shade above the y-intercept. So what I like to do is look at the y-axis. Here's my y-intercept. I know I want to shade above that. So that means I have to shade everything on this side of the line. I'm going to pause and do that. Let's say you couldn't figure out whether you should be shading on this side of the line that we did or on the other side of the line. What you can always do is test a point that's not on the line. So this one, I would always use 0, 0 unless it's a point on the line. This one doesn't have 0, 0 as a point on the line. So you could test the point 0, 0. If 0, 0 is the point, that means x is 0 and y is 0. Plugging that into the inequality, it's y, so 0 is greater than or equal to 1/2 times the x value, which is also 0, minus 3. By simplifying, 0 multiplied by anything is always 0, so that's why 0, 0 is a great point to test. That just eliminates that term. And then we have negative 3. You want to decide, is this a true inequality or false? 0 is greater than or equal to negative 3 is true. That means that the test point should be shaded. Notice that 0, 0 is shaded by the pink shading. If you had tested a point on the other side, like 10, 0, and plugged in 10 for x, 0 for y, it would have made the inequality false. That's why 10, 0 is not shaded by the pink shading. Now let's use another line for the blue inequality. Y is less than or equal to negative 2x plus 7. We're starting out at our y-intercept of 7. Use the slope negative 2. We already talked about that's down 2, right 1. These two lines also share a point. We said we are going to graph this with a solid line because of the equal sign. And that we were going to shade below the y-intercept. So if I'm looking at my y-axis here, here's the y-intercept. I want to shade everything below that y-intercept. So in other words, everything on this side of that line. Again, you could have tested a point like 0, 0. If you plug in 0 for x and 0 for y, it would have made the inequality true. It would say 0 is less than or equal to negative 2 times 0 plus 7. In other words, 0 is less than or equal to 7, which is true. Therefore, you should shade the test point. True means shade the test point. And notice the origin, 0, 0, is shaded by the blue shading. You'll notice that the pink and blue shading, where they overlap, it created this purple region here. This purple region, any point in this, including the origin, will make both of the inequalities true. In addition, any point on this blue line will make the blue inequality true. Any point on this pink line will make the pink inequality true. But the purple is the solution for the system. That's what makes both of the inequalities true. So we can't really represent that with one single answer. We have to represent that with a graph. Now go try the practice problem. Here is the correct answer for that. The solution region is that little purple part right down here. I had to graph it pretty far down and left to be able to find that, but that happens sometimes. So make sure you keep graphing until the two regions intersect. Finally, we will get our last example for chapter 0. This is a system of inequalities with separate regions. This one is a little weird because it's not in slope-intercept form. So before we can graph these, we need to put 8 is less than 3x minus y into slope-intercept form. That's y equals mx plus b, except it's going to have an inequality, don't forget. So it's going to have 8 plus y is less than 3x, and then subtract the 8 on both sides. 3x minus 8 is our expression here. And my other expression also has a slope of 3x, but a different y-intercept, so I know these lines are going to be parallel right off the bat. They both have a slope of 3, but a different y-intercept. So let's go to the graph paper and get these graphed. Alright, I got the coordinate plane set up, and I am going to start with the pink one. It's y is less than or equal to 3x minus 8. So I'll start with the y-intercept, negative 8. On this, some people might like to do open circles. If you're used to that, when it's not an equal to, you can use that, an open circle, to represent that 0, negative 8 is not a solution. It would make something like, maybe it would say 0 is less than 0, which is false. So it's on the line, but it's not a solution to the inequality. Next, I'm going to use the slope of 3. I'm going to go up 3, right 1. And that's right where my -5 is. So I'm going to put that over here. So I have space, up 3, right 1. And I'm just going to keep using that slope to find more points. If you want to put open circles, to remind you also that you need to connect these with a dotted line to show that the points here on this line are not solutions to the inequality. You must use a dotted line though. And then we're going to decide, should we shade above this or below this line? It says y is less than. So I'm going to locate the y-intercept and shade on the y-axis below that y-intercept, meaning that I'm going to have to shade everything on this side of the y-axis, or of the line. If you're having trouble figuring out where to shade, remember you can always test a point not on the line. Lucky for us, the origin is not a point on the line this time. So we could test 0, 0. That means x is 0 and y is 0. So we would have 0 is less than 3 times 0 minus 8. That simplifies to 0 is less than -8. That's a false statement. So we should not shade 0, 0. If we're not going to shade 0, 0, that means we have to shade on the other side of the line. Now move on to the blue line. It has a y-intercept of 4 and a slope of 3 as well. So I'm going to go up 3, right 1. I can also repeat that same pattern in the other direction by going down 3, left 1. But since these lines are parallel, no matter how many points I graph, they're never going to intersect. I'll draw it with a dotted line, since it's not equal to. The points on that line will not be a solution to the inequality. And I know I need to shade above the line because it says y is greater than 3x plus 4, so I'll locate the 4 on the y-intercept, shade above that on the y-axis, meaning I'm going to have to shade everything on this side of the line. Again, just like before, I could test a point, like 0, 0. So if I test the origin on this, since it's also not a point on that blue line, I would plug in 0 for x and 0 for y. That would give me 0 is greater than 3 times 0 plus 4, which simplifies to 0 is greater than 4. That's a false inequality, meaning I should not shade over 0, 0 with the blue highlighter. I need to shade on the other side of the blue line. Notice that on the graph, the blue and pink shading never overlaps. Whenever the shading doesn't overlap at all, that's a problem that has no solution. Sometimes, even with parallel lines, you could have a solution. Like, for example, if the blue shading was on the other side, it would have overlapped with the pink. Or if the pink shading was on the other side of the line, it would have overlapped with the blue. But since they're shaded on opposite sides like this, there's no solution. There's one more practice problem for you with a special solution. Here's the answer for that. Since those regions never overlap, it's no solution as well, just like that one we just did. And hopefully you're noticing that no solution is only possible with parallel lines. They have the same slope, different y-intercepts. But parallel lines doesn't automatically mean no solution. So you might still want to graph it out just to make sure. Don't just assume that parallel lines means no solution. Be careful there. All right, that wraps up our lessons for Chapter 0. Hopefully you've reviewed a lot of your algebra and we're ready to dive into Precalculus, starting with Chapter 1 next. See you guys. Bye.